Now we can go and do number 2. Since we're done with number 1, now we can do number 2. On number 2, we see they say that W is equals to ABC element of R cubed such that A3 is equals to C3 and V is equals to R3. So they say W is equals to A BC element of R cubed such that A cubed is equals to C cubed and V is equals to R cubed. Now we see we're in the 3D space, right? So now if we see here, we remember what we need to do. We will need to check if W is a subspace. And if W is a subspace, we need to check if the zero vectors in W. We need to check if addition of two vectors is in W. And we need to check if a scalar multiple of a vector is in W. Right. So what we're going to do now, we're just going to say solutions. Then we start by checking the zero vector. And remember, I said that how do we check the zero vector? So that first we need to let U to be an element of W such that when we have this U to be equals to A, B, C element of R3 such that A cubed is equals to C cubed, and we take some zero vector to be equals to, say this is E1, E2, A3, which is an element of R3. Alright, such that we're not going to say this here on the condition of the 0 because we haven't confirmed it. Such that when we take U plus the 0, we get U. And this will imply that our U is ABC plus our 0 vector is E1, E2, E3, which is equals to ABC. As usual, we add this. See, right? Then this will be A plus E1, B plus E2, C plus C3, plus A plus B equals to C implies A1 equals to 0, A2 equals to 0, A3 equals to 0. And we know here that this tells us that this is 1, A2, 3, which is equals to 0, 0, 0. And this is an element of R3, alright, such that when I take the first element, they will always be equal to the last element. Hence, this implies that this is an element of W. You see right now. Then I check the second one. Let's see the second condition. The second condition is that when I pick two vectors, U and V, which are an element of W, such that U will be equal to A, B, C, which is an element of R3, such that when I take the first element and cube the last element, they're going to be equal. If I cube the first element and cube the last element, they're going to be equal. So, from this, I also say V, I define V is equal to X, Y, Z, which is an element of R3, such that when I take X cubed, it will always be equal to Z cubed. Now I add them. Say then U plus V is equal to A, B, C plus x, y, z, which this will be equals to, now this will be as usual a plus x, b plus y, c plus z. Now we are required to prove, since this is an element of R3, we are now required to prove that when I take the first element, I cube it, it will always be equals to the last element. I cube it. You see that? So I can try to prove this. And remember here, this one is a cubed plus 3 a squared x plus 3a x squared plus x cubed, which this side also we have c cubed plus 3c squared z plus, that one is, I can say, three c z squared plus z cubed. So I can take the left hand side to prove it to be equal to the right hand side. So the left hand side is this. This will be equal to, remember that A3 is equal to C3, right? I can just put C3 here, plus, and then we have here 3. Check here. Since we see here that since A3 is equal to C3, this implies that A is equal to C. If I cube root all sides, you see right now, then here I know already that on A I'm going to substitute C. You see right? So I'm going to do that. And again, we know since this is equal to this, I can just cube root, and this will imply that x is equal to z. So I can just come and substitute there. You see right? Plus 3, we know that a is equal to c, and we know that x is equal to z. Plus c3, your x3 is equal to z3, right? X is equal to this. X cubed is equal to that. Then if we check, we realize that this is equal to the right hand side. You see right? This is equal to the right hand side. The right hand side was c3 or c cubed plus 3c squared z plus 3cz squared plus z cubed. Hence, u plus v is an element of w. I'm sure we say this. Now, since we have shown this, we can now come to the third condition of showing alpha and scale. So for us to show that, we need to first let u to be an element of w, such that u is equal to a, b, c, which is an element of r cubed, such that when I take a cubed, will be equal to b or c cubed. Right. And I take some scalar to be an element of our field, which is R. Then, if I take scalar times U, I'm going to get scalar A, B, C, which this is A, B, C. Now we are required to prove this is an element of R3. Now we are required to prove that if I take alpha A cubed, this will be equal to alpha C cubed. And if I take the left hand side, we realize that this is alpha A cubed, which is equal to alpha cubed A cubed. And here we know that we're going to have alpha cubed C cubed, since A cubed is equal to C cubed. We have said that there. And then from here, I can just substitute them back. You see, and this is equal to right hand side. Hence, alpha U is an element of W.